Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SaaS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. Your host is Tobias Macey, and today I'm interviewing Max Beauchemin about the concept of entity-centric data modeling for analytical use cases. So, Max, for people who haven't heard any of your past appearances on the show, can you just give a bit of an introduction?
Yeah, for sure. And I was trying to think how many times I've been on the show before, and then how many times we're planning together to get me back on the show too. So this is like part of a series of multiple dozens of episodes that we'll be doing together. A little bit of background on me. So I think to this community and audience, I'm probably best known for being the creator of Apache Airflow. So I started this project while I was at Airbnb in 2014. A little bit after that, also while at Airbnb, I started Apache Superset. So Apache Superset, for those not familiar with it, is a business intelligence, data visualization, dashboarding web application that's open source, right? So you can essentially download that, install that, and run that in your company just like you would run Tableau and Looker. And people are probably familiar with Superset in the audience, but like it has gotten really, really freaking good over the past like year or two. So if you haven't checked it out, since I first started talking about it, and 2017, 18 is probably when we launched it. It is good now. It is really, it's really solid, really competitive, better than some of the vendor tools in many regards, especially for a technical audience, right? So for people that are more technical, no SQL. The tool is more designed for the modern data practitioner too. So invite people to try it. And then I don't do much of a commercial bit, but like if you want to try Apache Superset, the best way to try it is on Preset. So I am a startup founder. So I started a company called Preset around Apache Superset, and the goal there is to offer a really awesome managed service around Apache Superset with bells and whistles, and it's all managed, and there's a freemium component, so you can try it, for free today, and you can try it and go and use open source if you want to. But the easiest way to try Superset, latest greatest version, is on preset.io. So check it out. Yeah, so founder now. I guess I'm more of a founder, but like very much an open source enthusiast. Love writing code, building communities, and more recently like building a company to that can fuel open source, right? So the idea is much more like how do we create something sustainable around the open source project, so we can be a little bit the parent or the foster parent for the open source project, and do all the difficult things, and really help the community. So for me, it was like how business can help open source disrupt in a symbiotic kind of way, much more than like, oh, let's extract the money out of this community. Like that's really not the goal. The goal is to have this symbiotic, like, capital infusion and open source, and helping us to get open source to disrupt and eventually dominate, in business intelligence.
Yeah, I definitely see Superset all over the place these days. Pretty much everywhere I look, if there's any sort of open source aspect at all to a stack, Superset's usually involved there. So definitely great work on that. And just a brief recap again for people who haven't listened to any of your past appearances, how you first got involved with working in data.
Yeah, and we could look back at the topics we talked about together too, as a series of like my shifting and ever evolving interest over time. But I first started a while ago, so like you could tell if we were on video how much like gray hair I have at this point. But I started early 2000 as well. First, my career started. I did 1 year of web development, which is kind of it's a great thing to be able to build apps, right? Regardless what your engineering career is going to be like, being able to build little website and little tools is super helpful. So I did a year of that early on, and then I got into pretty much data warehousing. So I was at Ubisoft, a bit of a company that's doesn't need to be introduced anymore, probably. at this point in time. But they, um, yeah, so there I started doing like traditional data warehousing. So I picked up, I'd had some classes in school, and I'm a college dropout, but I had like an IT program equivalent of an associate degree where I learned some SQL, some data modeling, a little bit of everything. In terms of building apps and coding, I guess we didn't call them apps at the time, but yeah, so I had done some SQL, some data modeling, and then got into data warehousing. Picked up the Ralph Kimball books at the time around dimensional modeling, and started building a data warehouse for Ubisoft, all of their financial data, retail data, um, pretty much covering the realm of the data they had at the time. And that was the start of a career in everything data, pretty much, right? Data. So I was the data warehouse architect. I was the business intelligence engineer, and then later on in my career, I joined more modern. I moved to Silicon Valley and then joined companies like Facebook, Airbnb, Lyft, um, and that's where I started, working on open source and doing what we call today data engineering in a more modern way.
Yeah, and a lot of people have credited you as being, to some extent, the godfather of data engineering as it's defined today, given your well timed blog posts of the rise and fall of the data engineer, which roughly coincided with the start of this podcast. So,
Yeah, yeah, I remember that was probably like one of our first conversation together. Yeah, so I remember at the time, and it's not like I invented data engineering, but yeah, I wrote the blog post that try to, try to define what it was and what it was not at the time. And clearly, for me, my experience is I joined Facebook a data warehouse architect, and by the time I left a few years later, I left as a data engineer, and we realized while we were there that what we were doing was not, data warehouse architecture or business intelligence. It was a whole new discipline with where different skills were leveraged in different ways, and the approach was completely different. So at some point internally at Facebook, we decided to call ourselves data engineer, and that I think I was inspired. There was an influential blog post called "The Rise of the Data Scientist" or something like that. I probably dug that out. That was pretty critical to that, to kind of cementing, defining that term, and creating that new role and persona. So I was like, hey, I'd like to do that for data engineering. I wrote that blog post, and yeah, rest is a little bit of history.
bringing us now to the topic at hand for today, brings us around to another one of your blog posts. So, writing is definitely one of your strong suits. So, appreciate all of the effort you put into that. And so, you wrote a post about this concept of entity-centric data modeling. And so, for people who haven't already read the post, we'll add the link in the show notes. So, you can either pause now, read it, come back, or just read it afterwards. But for people who don't want to take the time, can you just give a bit of an overview about what it is when you describe entity-centric data modeling and some of your process of coming to this formulation of the problem?
Yeah, so first, a bit of a disclaimer, right? Like talking about data modeling without schematics and images is a little difficult, or it's not difficult for me to talk about. It might be difficult for people to make sense of whatever we're going to be saying here. So I encourage people to read the blog post too, and we'll try to stay in the language territory as opposed to visuals to talk about it. But the core idea behind entity centric data modeling is to um, well, first, like maybe I'll talk about the driver of like why I wrote the blog post. But I've been a dimensional modeling aficionado for like 20 years, right? So I read the Kimball books a while ago. Facts and dimensions make sense to me. For those not familiar with dimensional modeling, go pick up that book. Though it is like fading in relevance in some ways, right? But if you're a data engineer, it's probably good to go and read maybe that's the original, the Old Testament. I don't know what the New Testament might have to be written still, but it's not a bad thing to go and read that. Still, the general idea behind dimensional modeling is star schemas, where some of the core principles is you have fact tables and you have dimension tables. Fact mostly contain foreign keys to dimensions and metrics, and then dimensions have the primary key of the entity, and then all sorts of denormalized things at the entity level. I'm not gonna get into Snowflake schema because I feel like it starts to get into like the area where visuals are helpful. If you want to learn more about dimensional modeling, check out the books. Um, but yeah, so I've been practicing dimensional modeling. I think over the past decade or so, we started to be much more pro denormalization in the Hadoop era. If you're not familiar with normalization, denormalization, you're probably in trouble for this blog post. You probably need to go and pursue your career in data engineering for a little while, read some articles, and come back to this blog post. But we've been pro denormalizing, the idea to have like more flat tables as opposed to a bunch of small tables with a lot of foreign keys. Right. Another concept we might talk about in this blog post is normal forms, first normal form, second normal form, third normal form. Um, but yeah, so going back to dimensional modeling, one thing that I've been doing and I've seen a lot of folks do in the past like 5 to 10 years is starting to bring metrics into their dimensions. And that can be really, really powerful pattern. In a lot of ways we can get into why it is powerful. It's a little bit of a digression as far as like if Ralph Kimball was on the show, he'd be like, "Wait, you did what? You brought some metrics into your dimension? Is that okay? Is that not okay? Like why are you doing that?" So that's one of the ideas of like yes, no, it is an entity-centric data modeling. It is virtuous and encouraged to bring metrics and dimensions. We have ways to talk about this and how to do that properly. So that we'll get into. Another idea is legitimizing also bringing data structures, native data, nested data structures inside your dimension tables, right? So now we have databases like BigQuery, Snowflake, or all databases have learned, JSON and complex data structures over the past decade, which was not the case when those early books were written, right? So it's a new set of tools that we have, and by the book, starting to put an array of objects into a table was probably discouraged. And now I'm saying like, hey, it actually sometimes it does make a lot of sense to do that, right? So those are some of the core ideas that I've seen done. Wanted to legitimize and offer a little bit of a framework as to how to do that, right? You bring metrics in your dimension. What do you do with time? Like do you have like a customer table? You're going to bring some metrics. Like, yeah, you might have cost of acquisition or lifetime value of the customer, but you might also want to pivot time, like how many visits and as this user visited the site over the past 28 days or 7 days. So I wanted to like legitimize some new set of practices and offer a bit of a framework or hints as to how to do that properly. Here's another thought too that's pretty foundational is and some of these ideas come from the field of feature engineering. And if you're a data engineer today, you may or may not know, depending on how close you sit to your fellow data scientists and your team, and whether they have a feature store and do feature engineering might differ depending on your organization. But I also wanted to take some of these concepts and practices that I've seen used in the field of feature stores and feature engineering, and then mash that into data modeling for analytics, as I've seen a lot of benefits of doing that. And feature engineering is extremely entity centric too, so that that kind of fits together. So in the blog post I talk about the parallels between feature engineering and entity-centric data modeling too. So that's a lot of stuff, right? That's a lot of information. I'm speaking fast. Hopefully people are still with us. I've lost 80% of the audience here, but yeah, we can unroll to and go deeper into these different aspects of it.
Yeah, there's any number of directions that I would love to go with this. Before we get too far down any of those paths, I also think it's maybe worth giving a concrete sense of what we mean when we're talking about an entity. Obviously, this is going to be different depending on your business, but from the, I guess not the broadest sense, but from a relatable sense, what are some of the ways that you think about how to go about defining an entity? What are the heuristics that you use to say this is a business object or a domain object within my the context of my organization?
Yeah. So clearly, this notion of an entity, we talk about it in the abstract here, right? But the reality is in a lot of cases, analytics are applied to businesses, and then your core entity as a company should be really clear to you, right? And while they may vary from a business to another, or from like a business vertical to another, there are some that are very universal, and like most companies have, that are very relatable. So the customer, right, like is a very clear business entity, right? So if you think entity centric data modeling, for a lot of people, that might be like entities like your core business entities, like your products, your customers, your users, your perhaps your departments, if you're in more of an HR world. And finance, it might be your business units, right? So these, I think, to me, if you look at the definition of what's a dimension in dimensional modeling, it's fairly aligned with that. One thing that's a little bit of digression here, that might be interesting yet a little bit confusing. When you think about facts, right, is an event an entity, right? Or is a when you look at your sales fact table, usually behind the scene, it's not that far from an invoice or an invoice line fact table. So I would say in data modeling, most things are entities, whether you want it or not. And the idea of like entity centric data modeling, when I named this approach, I was like, oh, do I go with entity? Because even if you look at like third normal form, like your OLTP type data modeling, like data modeling for apps, this is also very, very entity centric. So entity centric seems like it calls for high normal form, like third normal form. But in this case, it's really entity centric for analytics. So yeah, what are the big dimensions and entities that you care about in your business?
Another piece that I think is interesting to at least touch upon, maybe not focus on too much, is what you were talking about with this juxtaposition of analytical use cases for data versus machine learning use cases for data, where machine learning has largely been dominated by this concept of feature engineering, unless you happen to be doing deep learning, in which case you just throw a whole bunch of data and hope something useful comes out the other side.
Yeah, so I think in deep learning too, I think like really often you'll use, so feature stores can be used for deep learning. I believe it's just LLMs now is the whole new field of unsupervised learning, where now you can throw a bunch of text, right? And then, so it's not as, you don't need to have as structured data if you have a language model. But I think still in, if you want to train a neural net for a special purpose kind of type use cases, you still need a feature store, or you still need things to be like organized in a similar way. When you think about it, like for data engineers on the call here, like thinking about like what's so different about feature engineering or ML use cases, and what are some of the needs there. So typically in machine learning, I think you want to have like fairly like entity centric thing. So you want these very, very flat table with like a million columns. So let's say if you're trying to make prediction on, is a user likely to churn, right? So what you're going to need is for the user entity, a million metrics that might be related or correlated to the fact that whether they may churn or not. So you're going to say, okay, so I'm going to train a model with, where I'm going to give it data for a bunch of users, and for each users, I'm going to give them a million different attributes, or probably not a million, like most likely like at least 100, maybe 1,000 um, attributes related to this users that may or may not be related to their likelihood to churn. And it might be thing like time since last visit, right? That's a metric. How many visits did they have over the past year? and which part of the product they engage with or they don't. Usually as a column, like did they engage with feature A in the product? Did they engage with feature B in the product? All pivoted. So typically, the models like to receive data that is all pivoted. And then what, the underlying, what the machine learning model is going to do is try to find correlation, like which are the columns or metrics or combination of columns or metric that may predict or associate with their likelihood to churn, right? So just in general, the way you prepare a data set for machine learning is a really clear entity, in this case, the user, a metric that you're trying to predict, like whether they will churn or not, and then a million attributes that may or may not be related to that, and let the machine learning, model figure out what correlates with that.
And given those two different use cases, one of the things that I've been curious about of late is whether both of those different teams, so the data analyst and the ML engineer, are they both going to the same location to get the data, or does the ML engineer need their own feature store, feature repository, feature pipelines, and the data analyst uses the data warehouse and they're off in their own world? Or are we getting to a point where the data warehouse is powerful enough and flexible enough where everybody's actually just working on top of that same substrate of the data warehouse, but maybe with a different set of tables that are derived from those core sources?
Yeah, I think it's very intuitive to think like, hey man, we should share, we should be dry, right? We should like only have like one definition of these metrics and one way to model these things, and it should all be consistent, managed in the same repo, and we all, kumbaya, between like data engineers, data scientists. But I would say the needs are like intricately similar and intricately different, and similar. The needs and the constraints for on both sides are intricately different too. So there's definitely like, should they share? Should they talk? Should they align? Yes. Then can they use the same technology and processes and live in the same repo? In my experience, that doesn't tend to work so well. So I can try to explain like some of the bigger divergences on both sides. So on the feature side of things, there's a need often for online prediction, like live kind of streaming data sets, so stream not batch. That need may or may not exist on the analytics side. The kind of metrics they care about versus the ones we care about in the, call it the 90-day analytics versus the machine learning type use cases, they're not, there's a lot of common metrics, but there's a lot of metrics they care about we might not, right? Like, and then just the practices, the mindset, the personas, the approaches tend to be differentiated enough that it's hard to agree and settle on a place to work together. So I'd say give it a shot, but it's I would say your likelihood to succeed is is, I don't know, not guaranteed. I'd be really curious, like if there are people that do that successfully to an extent, that would be a really interesting, thing for the conversation for the show notes. But in my experience, these different personas tend to live in slightly different world, and they do share. At some point, they'll share some source table, right? Like you'll have like, you have your staging area, your work tables, your more curated schemas. They might tap into that, or you might have a shared layer somewhere. You're working effectively with the same data. The question is like, how far along you go together before you diverge into different systems or different use cases.
And so, bringing us back now to the space of data modeling, dimensional modeling, we talked a little bit already about the juxtaposition of entity-centric modeling with some of the more so-called traditional dimensional modeling strategies of star and snowflake schema, and we can maybe even lump data vault in there as well, if you're feeling adventurous. And beyond those established practices, what are some of the other competing modeling approaches that you've seen cropping up? One in particular that came to mind when I was preparing for this episode was the activity schema that's been popularized by a company whose name is escaping me at the moment, where every event just goes into one table and you just have an event type and you just query based on event type. I was wondering if you can talk to some of the other ways that you've seen people try to tackle this problem and come to grips with the increased compute power that we have now with the structural benefits that are offered by these dimensional strategies.
Yeah. So first, it's like, what is the inventory of of like the different data modeling, techniques that you might want to study or use as a data engineer today, right? Like what are the relevant ones? So you mentioned activity schema that I would probably best describe as like the cram it all in one table with more complex data structure, which has some virtues and frankly as a pattern that I've used for some parts of the data warehouse for frameworks that pivot time metrics and things like that. So we could talk about how an activity schema type approach can be user leveraged to produce entity-centric practices in some ways. Just like trying to enumerate. So I know there's Data Vault, I think that has some traction and some good literature, right? There's data mesh, which to me is I would dismiss as not data modeling and it's more like organizational, and it's about like how should you structure your organization. It's not really prescriptive in terms of data modeling technique. Yeah, so activity schema, data vault, data mesh. There's probably a bunch of other ones. More traditionally, then there's dimensional modeling. That's the Kimball one. There's the corporate information factory. It sounds like an awful term. That's the Bill Inman approach, which this one I think suggests a normalized data warehouse and then building data marts off of it. Kimball dimensional modeling talks about conformed dimensions. But yeah, I think it's a bit of a messy world, and there's nothing that says you have to pick only one of these religions too. And then there's been very little innovation in that field, right? Like, so if you're like, hey, what are the best data modeling for analytics blog posts or books that I should read from the past 10 years? I don't think you're gonna end up with a lot of reading material, Maybe because the topic is like, I don't know, or maybe it's like partially solved or partially unsolvable or not that interesting to people. And yet you have like now with the rise of the analyst engineer and people basically doing whatever the heck they want in terms of data modeling, right? Like be like, I'll just write a bunch of SQL. I'll just write mountains of SQL that derive derivatives and of other data set. And I don't know what normalization, denormalization means. I just run queries and produce data set, and we try to make sense of all of this. So given that, I saw that as a bit of an opportunity to write some content on data modeling. There's probably an audience out there. There's people thinking like, is it okay to put metrics in my dimension, or should I read a page from the feature engineering book and apply some of these techniques on my side? So yeah, it's a bit of a jungle out there, and the most comprehensive, I think, complete thing that's self-standing to me is the Kimball books, right? And it's 20 years old now. It predates Parquet, predates like Column Store, maybe in many ways, right? So some of the stuff in there needs to be freshened up.
Another interesting thing that I see in the community and have experienced firsthand a little bit is also the propensity for teams who are working with data to not even go through the modeling process of just saying, particularly with ELT and tools like DBT, to say, I've already got my data, I'm just going to write some SQL to pull together a few things into a table, and there we go. And then that works for a little while until it doesn't. And I'm curious what you see as the overall impact of tooling on the ways that teams approach that thought process of data modeling, data transformation, the downstream usage and impact of the ways that they approach that transformation and modeling stage, and also lumping into the tooling category the underlying database engines as well and the capabilities they bring. Just the way that all of that jumbles together to either encourage teams to think about modeling or to just go forth and hope for the best.
Yeah, I mean, there's one thing. There's a lot of virtues in making it easier for people to do things, right? And then Airflow did that in many ways. Like Airflow made it easy ish. I mean, not that it's super easy, but for people to manage and maintain and grow their network of data pipelines faster, right? So with that comes a lot of enablement, like more people can create more pipeline faster and manage more because they have this nice, UI to understand what fails and retrigger things and do change management in a decent or half decent way. I think DBT elevates that to a next level for SQL specific use cases, right? So making it really easy for anyone to that knows a little bit of SQL, a little bit of Git, to start producing data set and scheduling them running every day. The downside of making that so accessible is, well, if it's really easy to produce a data set, then people can create many data sets per day. And I think this controversial person on Twitter, Lauren, I think she talks quite a bit about how like the explosion of like there's a conspiracy theory on like Snowflake making money off of DBT, empowering people to create just these mountains of SQL. And I certainly don't think there's a conspiracy theory, but I do think that there's a conspiracy going on. Like making it easy for more people to do certain things brings a new wave of people that may not be expert in the art of, say, data modeling, and can lead to technical debt being created faster than it will, in a way that there's no hope to maybe fix it ever. So yeah, and specifically about DBT, something that's like very different from like with Airflow. Airflow has a very kind of scheduler approach. That's like, this job runs every day. So then it becomes kind of natural to say like, I'm going to process a day worth of data every day. If I need to reprocess a day, I can go and just reprocess that day. DBT has a simpler approach around that. It's just like write code that either rebuilds the whole table every day, or you can set up these incremental loads. And the approach for incremental load is catch up, right? So like write code that if you're in incremental mode, it will figure out what range to run, and basically it works like a compiler, like data build tool. It's a build tool. So that makes it maybe a little bit easier in a way to author these jobs. I mean, make it extremely easy to be lazy too, and just like refresh the whole table every day. So when you run DBT run in a lot of places, it rebuilds the entire data warehouse every day. That works for a startup. That probably doesn't work when you start having a little bit more data. You have to go and start thinking as a retrofitting, like how do we bring in incremental load to that world. So yeah, I think in this new wave of like analysts, engineers, which know SQL, they want to visualize data. How much do they know about and care about data modeling, and how much do they know and care about data modeling? I would say like a little bit less than what I have observed personally. It'd be better if everyone knew a little bit more about data modeling and had a little bit more rigor around how they think about creating and managing and maintaining these data sets forever.
Absolutely. Another interesting aspect of the modeling question is who are you doing it for? Where in the Kimball era, it was very much for the DBA and the business intelligence engineer maybe working together to say, okay, this is the report that I'm trying to build. So these are the facts and dimensions that I need. This is the way that I need this to be transformed to be able to write this report. 6 months later, okay, I've got a new report. So we're going to go back and update to the set of tables. Whereas now there isn't that clear connection between the way that the data is coming in, the way it's being transformed, and the way it's being used. There are sort of interfaces between each of those stages of, okay, I've done my job. I don't know what you're going to do with it, but good luck. And
Yeah, no contract too, as to like, is this private? Is that public?
right,
Who uses it? It's like I have baked a thing, and you can bake on
exactly.
top of it. You don't have to let me know if you do, and change management is just hard in data too. So I don't think we respect the problem of change management well, in data engineering. Just put it out there. People will latch something else on top of it, and it's all SQL all the way down.
And so to that point as well, dimensional modeling, star and snowflake schemas, those are very technically oriented. There's a lot of detail to it. Once it's there, it's very valuable if you know how to use it and what you're trying to get out of it. I'm wondering, going back to the entity centric modeling that you're proposing, what are the players in that space of saying, okay, I'm going to build this entity centric model because now it's easier for you to be able to self discover what are the things that you need to know, what are the ways that you're going to use it, what are some of the downstream benefits of the entity centric model in terms of building that interface between the data engineer or the analytics engineer who constructs it and the downstream consumers of that data?
So first, like going back to like who was the star schema serving, or who did we data model for in the past? And certainly we're not catering to a SQL savvy organization of people are going to go and run SQL, connect to the database and run SQL. We did it in service of the BI tool. Like that is really clear to me that star schemas, dimensional modeling, Snowflake models were there to power a BI tool that had a semantic layer, right? And I guess now we're getting into the semantic layer, which I think we have to, but historically, tools like business objects, MicroStrategy, SQL Server Analysis Services, even like a tool like Looker today, um, they expect to work with fairly complex schemas of data. So they won't do super well typically with like third normal form, type model, but they do very well with these star schemas. Now, do humans do well with star schemas is a question too. So if I deliver, well, let's stay on the semantic layer for a moment too. So if you build the schema or your data model and service the BI tool, then that assumes that you have to put this semantic layer on top, right? And that promise the semantic layer is self-service. So in tools like business object MicroStrategy, Looker, you can drag and drop these business objects like your dimensional attribute and your metric, and then the tool will figure out how to query your underlying complex star schema to serve that result set or to eventually power your visualization or dashboard. Now, there's some big problems with the semantic layer. So first, and I wrote a different blog post on this one. I encourage people are interested more in the semantic layer. I wrote something about dataset centric data modeling. Entity centric builds on top of dataset centric, but dataset centric says in general the interface for the BI for the consumption, whether it be a BI tool, a data scientist, or someone writing SQL, is a data set or can like, it's really great when it's a data set. It's easy for people to reason about tabular flat tables. It's nice to not have to figure out which joins to make when you don't have to. And that's some of the ideas behind entity centric data modeling too, where if you have everything around a customer in a customer table, including metrics, activity, engagement, likelihood to churn, um, then you're in a good place in terms of having just to understand the table you're working with, the column it has, and their definition. Then you have to go to a map to figure out like what do I need to join here to augment this data. Yeah, so getting a bit deeper into like serving the BI tool. So now you have multiple BI tools. So most organizations have multiple BI tools for a variety of reasons we could or cannot get into, but the reason why is usually like, hey, there's different generation BI tools. There's different personas in your organization that prefer. There's new BI tools coming on the market. There's a great open source one called Superset. You can go and use it and start using today. So people accumulate multiple BI tools, even through acquisition sometimes, or different business units wants different BI tool for whatever reason. So then if the semantic layer are not universal and open source, they are proprietary to the BI tool that you use. And they are fairly complex, hard to manage. I talked a little bit about change management before. Change management in data engineering is really hard in the data warehouse and the transform layer. It's also hard in the semantic layer, and keeping these multiple BI vendor tools in sync with your evolving schema is quite a challenge and is duplicative of work, right? So if you put a lot of that, how do you query this star schema in that semantic layer, and you have multiple semantic layers to manage, you're a bit in trouble. So for me, I argue that in this era where we don't really have a good universal reusable semantic layer across tools, it's better to put more of that logic in the transform layer and to denormalize further. And then you end up with this who you are serving. So in a perfect entity centric modeling type world, you have these very rich, very comprehensive entity centric data sets that can be used and reused across BI tools by different personas, by people who write SQL, without having to really understand complex underlying data models, right? So I want to do a customer bound analysis, then I'm going to pull the customer table, and great, it has 200 well documented columns in different groups and with some really clear naming conventions and descriptions. And it has everything I need for me to do really deep analytics for my customers. Like I want my customers who are likely to churn, who haven't been active in the past 90 days, who have acted in response of this, um, ad campaign or whatever it may be, and to have that at your fingertips or SQL tips, there. And then that can be used in your, as a source for your Superset dashboard or your Tableau as a Tableau extract, or, by a data scientist in a notebook, and can be much more comprehensive because tabular data sets are just easy and natural to reason about.
And so, for people who are trying to figure out what is the modeling strategy that I'm going to use, or they are in that situation of I've got a whole bunch of source tables, I've got a whole bunch of derived tables, but there's not really any rhyme or reason to it. What are some of the tactical aspects of iterating towards a workable entity centric domain model that they can build and maintain and evolve for their organization?
Yes, I would say you probably in your warehouse today already have, like, your core business entities are probably very, very well represented in slightly flat table, right? So you probably have some sort of central, or master central customer table, or if your business is in supply chains, you probably have a very rich like warehouse table somewhere that that has the bulk of everything that you should know about a warehouse. If you don't have one, then I would argue like you should build one, and then how you build it, whether you use a staging area and work tables and a back room and front room type approach. There, I would say probably stick to your internal practices as to how to do that, whether you do it in Airflow or in DBT or in ELT or in Spark. I think is also something that is very kind of cultural and like unique to your organization. If you have a blank slate, which like I don't think many of the people, like who on the call, if we had people on the call, who on the call here as a blank slate and gets to define their nomenclature and data modeling practices for their organization. That happens very few times in that era. That doesn't last very long usually. But I think that'd be an interesting question too. If you have nothing today, where do you start? Could do an episode on that. But assuming you already have practices in place, tooling in place, and a reflection of your core entities somewhere in a queryable place, the question is like, how do you augment it to be even more useful? Some of the ideas behind entity centric is, yes, you can and should bring metrics, like numerical metrics, to your dimension tables, and that we can talk about um, how to do that. I touch on it in a blog post, but it's fairly complicated and abstract. The big question too is like, how do you bring time into that, right? Like, so fact tables are usually combination of foreign keys, an event, some metric, and a time, one or multiple time dimension. Now here we know we're in a table in the entity centric model. We're in a table that has a really clear grain. The grain is one row per entity per instance, right? So in the customer entity centric table, there's one row per customer. Now, if there's probably dozens, if not, dozens of metrics that are very, very key and relevant to qualifying that customers. How do you bring the time dimension and columnize it is an interesting question that I talk about in the blog post. The first thing is to bring these, I call them time bound metrics. So, say for a user table, call it visits or certain types of actions seem really important. And the time dimension for that is, well, okay, I can bring the total number of visits that this user has had, right? So it could be like me on your podcast. I've on your podcast website, I visited in total 50 times over the past N years, like almost a decade now, right? So so that's a metric, so that I would call life to life to date visits. But then it's really interesting to get something like 7-day visits, 28-day visits, 90-day visits. So then for each user in this case, you have a new set of columns, one that might be called, say, 90-day visits. Now, you probably want something similar with time pivoted listens, right? Complete listens, partial listens, average completion of, does this user, typically listen to the whole episode and snippets, or how much they might fast forward, how many times did they fast forward on their last listen. So there you have to think about what are the metrics that are most useful in relation to that entity. In this case, say visit, listens, percentage completion of listen. And you have to think about what are the time frames that are relevant to your business and time analysis. Typically, 7 days, 28 days, 90 days, 1 year, life to date, and then start pivoting these things, right? Start computing and pivoting these columns. Now, like one thing I talk about in the blog post is like having all of these time bound metrics that are rich and useful make a new class of analysis very, very natural and simple, right? So if you have to join to multiple fact tables to go to do like intricate time filtering to try to gather that together to run an analysis, you might not bother, right? Or you might not bother on like, okay, I'm going to do this complex join to get the number of like 28-day listens for that user. But if they are there at your fingertip, all of a sudden it becomes really easy and natural to do segmentation and engagement analysis and like give me the users, or targeting, right? Like give me the users that have not listened to any of my podcasts in the past year, but I've demonstrated interest on something else that is relevant and use that for targeting. Like I'm going to shoot them, this email for them to re-engage with this episode. So as these tables have a mix of, say in the case of users, they have user attributes like the traditional user demographics type things, but you enrich that at your fingertips with a bunch of like metrics that are very relevant to your business and timely too, and that can be extremely useful.
And as an extension to that exercise, what are some of the specific elements that maybe introduce added complexity, or maybe it's all the same thing when you're talking about working across multiple different sub organizations or business units within a larger organization, particularly thinking in terms of enterprise users, where they have multiple different entities or categories of entities or bucketing of entities that they maybe then want to stitch together across the entire organization to be able to get a lateral view of everything at maybe a higher level.
Yeah, I mean, in some ways, this type of data modeling like enables you to have a more like, a 360 view of the entity. I hate that term. It sounds so like marketing-y, but like, okay, well, we have you take a really core entity, the user, and then of course there's some metrics that matter most to, say, the marketing department and to the sales department or to the product department. They're like, oh, how are the people engaging with the product, which features are they using? But I would argue that in the end they're all like useful features of the user that may or may not predict their behavior, or may not be relevant to another department. So in the context of a feature storage, like cram more features in there that may or may not be useful or predict the behavior you're trying to predict through machine learning. But I think in this case, one challenge is clearly on the consumption side, if you have like hundreds and hundreds of columns for a user, then you're like, okay, which ones of these columns are actually make sense, are usable, or fresh? There's some challenges around just latency too, because now if you have to wait for the entire data warehouse and all the facts to come together for your user table to be ready. So and then there's like a documentation issue of like, what does the column called M underscore LTV underscore visit QDA, like what is QDA, like I don't. So I think there's a documentation and issue around it of how do you document these metrics so that they are actually relevant to people. There's also some issues potentially around performance in the world of column stores. If you have super wide table, it doesn't really matter. But in the Parquet file world, now you end up with these like Parquet chunks that don't have a lot of rows because they have a lot of columns in them. So there's like some techniques to be applied there. The latency one, the spaghetti issue, is like now your dimension table and your DAG depends on your fact table and your DAG, and the fact tables depend on other things. So you can get into circular dependency type challenges too, because now the complexity score of building your user table is not just like, oh, get all the demographics and be done with it. It's build all of your fact tables and pivot time and build 100 metrics and cram them into your user table. So that brings a ETL kind of DAG complexity set of challenges too. So in the blog post, I talk about some of these things. I talk about what I called vertical partitioning. That's one idea, to say different groups of attributes can actually be stored in different user table. So you would have use a table maybe called dim user extended with all the fields, but you might have dim user marketing with different subsets or groups of columns. There's probably a little bit more to it, but I talk in the blog post too around like how to deal with the circular dependency issue. And the idea there is to have an extra layer in the warehouse. So people familiar with the idea of a staging area, that's where you receive all your data that's very raw from the different system, mostly unprocessed and raw ingredients. The same way that a staging area for a warehouse is just where the trucks unload, and then there's the back room and the work table. So I'd say like there you would do a bunch of entity bound work and fact bound work. And then you have, I think I forgot if I call it a shuffle layer in the blog post, but that's where you pick from these like pre-made assets and merge, call it like entity attributes and facts together. There's no perfect way to do it, and it's a little bit at your discretion given your style and practices. But yeah, so those are definitely like some of the challenges that come with with this approach. One thing is like I think progressive adaptability of any methodology is really important, right? You're not going to go from what I do star schema now and we're moving to entity centric modeling. We have to rewrite the whole warehouse. No, right? It's like, okay, at first it's like, how do we sprinkle some more metrics and nested structure into our dimension tables? Like now that we know it's okay to do it, where do we start? Like what are the top 3 user useful metrics for this business, and let's just start with those.
Absolutely. And also the entire concept of building the table structures around these different entities also brings in the question of entity extraction, which is a whole nother episode. And so in your experience of working through this problem space, documenting these concepts of entity-centric modeling, working with the customers that you have at Preset who are trying to drive these different insights and visualizations of their data based on the different domain structures that they've built up in their warehouse, what are some of the most interesting or innovative or unexpected ways that you've seen people approaching this practice of entity-centric modeling?
Yeah, so we have limited visibility as to like exactly like what our customers and users do, at Preset, like and for good reasons, right? Like so we cannot get into your private data warehouse in any way. One thing I can talk about is how I've seen, I would say over the past decade, like since the beginning of the Hadoop era, how people who didn't come from a background of say star schema or dimensional modeling have been modeling their table, and some interesting use cases that we've seen emerge over the years. But I think when I first saw the what I call the time bound metrics was at Facebook in a table called dim user, and dim user was the most used table in the entire data warehouse of all of Facebook. And this dimension table like had hundreds, probably thousands of columns that had to do with their behavior on Facebook, or like basically everything related to a user was crammed back into this, or not everything was crammed back into this, but like things like, so say if you work on a photos team, you might want to know how many photos does this person have uploaded over the past 28 days, right? Or are they a tagger? Like, do they tag people in photos? Are they, do they use search? Do they, and on what time frame? So we start seeing a lot of like metric underscore 7 day, underscore 28 days, underscore 90 days. And for the data engineers, I was part of the data engineering team, and someone on my team was working on making sure this table is so large and so useful and so multi-dimensional that it became like it had a dependency on just about everything else in the warehouse and everything dependent on it. So it became like a very, 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 very key hotspot or focal point in the warehouse, both in like what it took to build it and how much it was used downstream. But then once you have that, I think the real thing that's really interesting is like once you have that at your fingertips, then doing things like cohort analysis and segmentation becomes very, very natural, right? You don't need to be go and figure out where's the data mart for photos and photo upload and how the heck am I going to join this. It's more like, okay, now I have a table where there's one row per table, and there's the bulk of everything I might want to know about this user, is there at my fingertips. So I can start saying like, hey, the users who did this, who did not do that in a certain time frame or in a different time frame. There's a lot you can do there. One thing too that existed there that was like very much a pattern. That's something I talked about in my functional data engineering blog post a while ago too, is the idea of snapshotting dimensions too. So that means not only you enrich your dimension um, with things like time bound metrics and nested structure. And we could get into nested structure a little bit more, like like what are some examples, like why is that relevant? But so not only you have like a super rich entity-centric table. They call it dim user at Facebook with billions of users and a million attributes about them. But we also would snapshot these dimensions. So you could do basically every day there's a new partition added to the dim table with all of the users. So if today you have 10 billion user, yesterday you had 9 billion 900, and then you can do time series analysis on these rich tables too. So that's something I do talk about in a blog post, and in general, I think is a good practice. So if you treat your data sets as immutable, something that's very natural when you build your dimension is to create a new snapshot of your dimension table every day. And when you have that, when you have this table, it becomes really natural to do time series analysis on your populations, right? So here you could say, give me the percentage of users who visited more than 6 days over the past 7 days and how that's evolving over time. So there you would use a metric called L7 visits, which represent the number of visits over the past 7 days. So you could say, which percentage of my users visit more than 6 out of the past 7 days? Okay, I got that. I can give you a nice big percentage. But how is that evolving over time? You do that through the idea of snapshotting your dimensions, being able to do time series on your dimension table. So that one is a little bit more controversial. You don't have to do it if you do entity-centric data modeling, but I think it's just a great practice to do that. And once you do that, of course, there's compute costs associated to that, right? Because now you're storing your whole snapshot of your whole dimension every day. But then the empowerment in terms of like the kind of analysis you can do very easily on these tables is really, really powerful.
And in your experience of working in this space and trying to distill the different requirements and use cases and capabilities around data modeling, what are some of the most interesting or unexpected or challenging lessons that you've worked through?
Yeah. Well, so I think the thing that's really difficult with data modeling is that there's no the best practices are not clear. They tend to emerge culturally within an organization. There's different like now everyone's been invited to the party, and there's a wide spectrum from amateur and people trying to figure it out all the way to experts that really know their art. And right now we're all working together, right? Like I've seen people make like gigantic mistakes in terms of like just basic like SQL writing and data modeling logic, just like joining on a field that's not unique, like doing these Cartesian joins, right? That just like, and they're just not aware that this is going to be a problem, or right. So there's some like very basic mistakes that get made. There's also people who don't know Git, so we've seen people like kind of Git push master on in certain areas that they use a Git GUI and they don't really understand how Git and branching works too. So one thing is like, if you look at the distribution from amateur to expert, there's a lot more amateur now that are empowered, and that comes with empowerment, but some risk and some issues too. So that's definitely an emerging pattern there. But yeah, and then in terms of like how to teach the data modeling type of, how to educate people on that is kind of unclear because there's no Bible you can point to really. So people have to look at like how other people do it, do a little code review and try to figure it out. But yeah, it's as if like we had invited a bunch of people to software engineering that barely know how to code, barely know how to Git, and that comes with a set of challenges. And the challenge is education, I think, in a context where there's not a lot of material to train people. So that I guess like the DBT community has empowered a lot of that, right? So people can go and get a lot of resources from, say, the DBT community and the DBT Slack and the DBT documentation, but still there's still a gap in making people experts and tech depth. To me, even for a seasoned expert data engineer that's really good at data modeling, it does feel still like data pipelines are tech debt from day zero. So now we're dealing with a much bigger issue at scale, like these mountain of SQL that are growing and brittle. And I don't know if we'll ever kind of dig ourselves out of that hole.
And for people who are working through these exercises of building up their data architecture, working in their data warehouse, what are the cases where entity-centric modeling is the wrong choice and they're better suited with standard star schema or activity schema or wide tables or just no modeling at all?
Yeah, no modeling at all. Or I think there's a bunch of things that have become practices that we used to do that don't make sense anymore. I would say don't start with entity centric. Just start by, I think anything you're going to do is going to be in some way entity centric, right? You're going to look at what are my business objects, like what are my business entities and how do I make sense of them. I know one thing that's a bit unrelated to modeling per se, but one thing that's happening is like with the rise of the 5 tran Airbyte, Meltano, and other like the data sync. Like one thing we don't do anymore is like writing data sync, right? Like in there we inherit comprehensive models from these tools. So at least you don't have to data model the staging area. So the staging area you get it, it lands into your data warehouse. I think one mistake that people tend to do and a bit of a pitfall is to go straight from that data sync to report, right? Like what is the SQL that I can run to create the report directly from my raw tables? And I think we all have figured out, over the years that you need some sort of like middleware there, I mean, like middle section where you're gonna go from staging area into like pre-transformed data and clean up and have a bit of a layered approach to your warehouse. I would say like don't go straight from your raw table into entity centric or into reports, right? Like think about like a layer that's much more like a probably something like a star schema to start with. So I would say like thinking about facts and dimensions in that first layer and the early layer is good. And then how do you bring your facts and your measures into your dimension? And maybe is a concern once you've solved the area of more like modeling your facts and dimensions.
And as you continue to work in this space and try to distill these various ideas and workflows and use cases, what are some of the predictions that you have for the future direction and adoption of entity centric modeling, or maybe some other modeling techniques that are waiting in the wings to come and obtain dominance?
Yes, I would say I like to see the, I believe it's called activity schema idea, right? I think there is a place for these generic metrics table. So we talked about like the metrics layer in the past and the feature repository. As much as like what we're talking about here today in terms of like entity centric modeling is like an entity bound table with a lot of columns. The question of like how you get to a lot of columns, I think somewhere in your data warehouse you need more of a metric, centralized metric table, where that one would be a very thin table that is very long, that are very, very high, right? And that, or by high I mean just the formatting of that table is not wide, it's thin. And what's typically in those tables, it will be something like, what is the time, what is the metric name, what is the entity name, or the entity type, the entity ID, and what is the value for that metric. And these are generic schemas that allow you to store things like events or metrics in time in a very kind of thin ways without having to change your schema. So I think we see that tends to exist quite a bit, call it a metrics repository or a feature repository. But it's pretty common to go have that table that is metric bound, entity bound, and time bound. So I'll try to repeat it. Like, but yeah, it's a very common pattern. You have a table that has something like entity type, customer, entity ID, entity one, metric, visit, and value, and time. So it would be on that date, this person for this metric as this value. So once you have these very generic tables, you can do a lot of that pivoting I was talking about before. That's more like, okay, now I want to compute 7-day visits for all my users, 28-day visits for all my users. I want to do that in one big scan. So once you have this table, it becomes much more natural to pick and choose how you're going to bring metrics into your dimensions. And that table, or that pattern is close to what I believe activity schema is about, and I believe is a place to loop back to what we were talking about in the beginning of the episode. That may be a place where data scientists and data engineers can collaborate and share definitions upstream for their own pipeline, right? To agree of like what are the metrics, all the metrics we track for each entity type and on what time frame. So there's probably much more to be written there. Like maybe there's a question like, how do you take something that's activity schema, entity centric, and produce entity centric table off of those. And I want to say too, like there's one thing we didn't talk about, which is, I said early in the episode that I wanted to legitimize bringing metrics and time bound metrics to dimension tables. Another thing I think that's important is bringing or allowing people to bring nested complex data structure inside dimension tables too. And going back to the podcast user listener table we're talking about, like maybe it does make sense to have an array of what are the last 5 episodes the user listened to, right? Like for whatever reason, like, and if you wanted to do that, well, you're not going to create one column called, last episode they listened to, previous episode they listened to. And if you want to track like what percentage of the episode they listened to, probably want, okay, what is the episode ID, episode name, and what percentage of the episode did they listen to? Okay, well, now you'd have 3 columns times 10 episodes that we'd have to manage this dynamically. So then, like, well, this is to me really valid information, really core information to the user, like 10 last episode. I want to put that in the table. Well, put an array of of structs in there and put it in there, and it will be easy for retrieval with a little bit of a JSON extract type function, or whatever the database of choice that you use offers to query this. Now you could do a nest type operation, and if you've seen those in SQL, but you could say, hey, if I have an array of 10 things, you can say generate, pivot that into 10 rows into my query. And people know how to do that now. Like it comes naturally for software engineer to work with data structures and pivot things. So don't necessarily abuse that. You don't want to put all the facts, about all the users as necessary structure, but it's something that you can do for things that are best represented that way too.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, as usual, this is, I don't know how many times you've answered this, but from your perspective of today, what do you see as being the biggest gap in the tooling or technology that's available for data management?
Yeah, maybe I'll go on. We talked about this just to stay with the theme of the episode. I think I would say like education and data modeling. Like it'd be great if we had like data modeling 101, and maybe that's like somewhat provided in and around like say the DBT community. But it's like what even if it was just like the 30 things you should know before you go and pile on your SQL to the mountain of SQL that your organization has. In terms of, I think there's much more to data modeling in that, but data modeling is a component of it. So, things like if you work with SQL and you create data set, you should know what like normalization, denormalization means. You should know, what a dimension and a fact is. So what is that vocabulary? And there's a bit of a gap there, right? If you talk to 10 different DBT users, they might not use the same nomenclature and practices and conventions. So we need to zero in here on a set of like knowledge that people agree about, or even just like definitions and terms that everyone knows that is close to that area.
All right. Well, thank you as always for taking the time today to join me and share the work that you're doing and your thoughts on this overall space of domain modeling, the benefits of entity-centric approaches to that, and the ways that our newer compute substrates enable more detailed approaches to data exploration. So appreciate you taking the time, and I hope you enjoy the rest of your day.
Yeah, it was awesome to be on the show as always, and I'm sure I'll be back soon enough. So enjoy your day too.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.